Problem number 1 involves a piece of nichrome wire, AWG number 30, which, as we saw earlier, just specifies the cross-section area of the wire. And AWG number 30 has 100 circular mils, which means that the diameter is actually 10 mils, which is equal to 0.01 inches. And then we can convert that, this being diameter, we can convert that into area by taking the cross-section area to be pi times d squared over 4. And this gives us 5.07 times 10 to the minus 8 meters square. Okay, we'll need that information as we go through the problem, because what we're trying to do is to find out what length of nichrome wire we would need to obtain a resistance of 1 ohm at 100 degrees Celsius. The resistivity at 20 degrees for nichrome is 1.08 times 10 to the minus 6 ohm meters. The alpha, that's the temperature coefficient, is equal to 17 times 10 to the minus 5 per degree Celsius. And the value then of rho at 100 degrees would be obtained by taking the alpha, the value of rho at 20, which is 1.08 times 10 to the minus 6, and multiplying it by the quantity 1 plus alpha 20 times the temperature differential, which in this case would be T minus 20, or we'll get 80 degrees for that part. So rho at 100 is 1.08 times 10 to the minus 6, multiplied by 1 plus, now alpha at 20 is 17 times 10 to the minus 5, and the temperature differential is 80 degrees Celsius. This turns out to be 1.095 times 10 to the minus 6 ohm times meter. So now we have rho at 100. We can go to the next equation, which says that the resistance is equal to rho at 100 times the length divided by the area. Well, we want the resistance to be 1 ohm. We know the area, which we just found a little while ago, as 5.07 times 10 to the minus 8 meters squared. We know rho, we just found the rho a little while ago, and that was equal to 1.095 times 10 to the minus 6 ohm meters. So in this equation, the unknown is L. And if we solve for L, the length of wire, L turns out to be equal to R times A over rho at 100, and this is equal to 0.0463 meters. That's a very short piece of nichrome. The resistance of that same piece now at 20 degrees is a proportionality between rho at 20 and rho at 100 times the 1 ohm. And the rho at 20 is given from the beginning of the problem statement as 1.08, we can find it in the table, 1.08 times 10 to the minus 6, and the rho at 100 is 1.095 times 10 to the minus 6. This ratio gives us 0.986. That would be the resistance of that same piece of nichrome at 20 degrees, a little less than it was at 100 degrees, went from 1 ohm down to 0.986 ohms.